Alright guys, so welcome to part 8 of building my ICF house. So in this video, we're going to be installing the electric. So we're going to be skipping around a little bit because right now is before the pour of the floor. And that's because I wanted to run the conductors in the conduit before I even pour this floor, before everything gets frozen, just in case there's water in the bottom of the conduit. I don't want it to freeze up and then block the conductors from going through. So here we are the next day. That poly braid wasn't working, it broke. I think it has like a 500-pound test on it, but it was too much. So we're gonna use a cable. I put a steel cable on the other end, so I'm gonna pull this out until I get the steel cable, and then we'll pull it back in. Yay! Let me bring you up to speed here, show you what's going on. So everything that you saw so far was before we poured this slab here. Let's just take a little peek at that. It's got 2 inches of snow on it. So I ended up waterproofing that, putting some insulation on. That way that whole stairway is covered, waterproofed and insulated, and it's working pretty good. There's no leaks in there. I put a door here. And it's really nice and warm in here. And all I have is this little space heater set on low. It's at 750 watts. And it's able to maintain 51, 52 degrees in here. So here's where we're at. I want to put my sub panel right there. The reason I call it a sub panel, not a main panel, is because the main panel is actually out on the pedestal there. It's a meter combination panel. So anytime that you're coming off of that with another panel, that's automatically considered a sub panel or a utility panel, service panel. So we got our conductors coming through here. This is 3 4-aught conductors and 1 2-aught. So there's 2 4-aught hots, 1 4-aught neutral, and then a 2-aught ground, which is this yellow wire right here. So ideally this conduit would have been better if it was like another 18 inches up or 18 inches down, because then I could have fed it through that panel from the bottom or the top. Right now, where I have it mounted, it's kind of like in the middle of where I want the panel, so it's kind of inconvenient. But the reason I did it like that was because on the outside, I didn't want it any lower, because then water could be draining, because then from the service panel to here, it's draining downhill, and then I'd be getting water in here, so I didn't want that. And then I didn't want to have it any higher, because then it wouldn't be deep enough outside, and I'd have to fill the grate up higher than I wanted to just to get my 24 inches on the top. Well, this set of conductors right here is meant for underground burial, so it's a URD wire, and I could have buried this without conduit and just used the conduit to come in here and over at the panel just to go up. But I never do that. I always install a conduit. Although right now, conduit is extremely expensive. So it would be the time to start considering getting some sand and burying service lines in that instead of using conduit. But I just like the idea of being able to replace the conductors if you ever need to by having the conduit in there. Plus it gives it extra protection too. The panel is going to be right here, and like I said, that's in the middle of the panel. So what I need to do is come off of that and turn into the panel. So the best way to do that is with an LB, and this is an LB. So the problem with this LB is that it doesn't have enough fill space in it. You can buy ones that are a little bit bigger than this. If you look inside of here, it's hard to see on the camera, but with this model of an LB, you can only put 3 2-aught conductors in here. So that's not gonna work. So what I came up with here is to use a 2.5 inch LB and reduce it down before and after. You can see there's a huge difference between this one and this one. And that's only 2.5 inch conduit, and that's 2 inch conduit. You wouldn't think there's a big difference in them, but there's more than double. 63 cubic inches, and this is 179. So there's more than double, there's almost triple the amount of space that there is in there. This is the main meter pan combination panel. So this is a 200 amp service panel as well as a combination with meter pan. So the nice thing about this is the fact that you can shut this off. This is 200 amps, and you can shut everything off from here on to work on it. So there's 3 of the same size conductors here, and I need to identify and keep consistent which one is the neutral, since they're not marked at all. So I'm gonna mark the one that's neutral with white, but the first thing I need to do is find out which one it is. So what I'm gonna do is I'm gonna take 2 of them, and I'm just gonna link them up together, and then I'm gonna go on the other side and check with a multimeter for continuity. And then the 2 that have continuity together, I know are the 2 hots. The one that doesn't, I'll just label that as the neutral. So these 2 conductors are touching now. So now I just got to check for continuity on the other end. Guys, this is what's nice about having a waterproof structure to work in right now. Blizzard outside, but nice and warm inside. Nice and dry and out of the snow. Just to test it out, make sure it's working. All you're trying to do is find continuity. That's as simple as it gets. All right, so we know that that's probably going to be our neutral right there. So I'm going to guess that these 2 are the ones that have continuity. See? So now we know this is our dedicated neutral conductor. So we're gonna go ahead and just mark it just slightly for now. I'll mark it a lot more when we go to hook it up. So these are the ones that had the continuity together. So go ahead and just mark this one. So I'm gonna mark this whole line in here. That way this is marked for being a neutral. Three continuous lines is all that you really need. Doesn't have to be super neat. We're gonna cut a lot of this off anyways. So we just turned a feed-through panel into a main breaker panel. But this isn't the main panel, this is just the main breaker panel. This is still a sub panel or a service panel. So because this is a sub panel or a service panel, if you want to call it that, you can't mix up the grounds and the neutrals. So these buses here, I'm going to leave for the neutral because they're already connected up here. They're connected together and they're connected right into the neutral. So I'm going to leave those as a neutral because this box has a plug-on neutral for the arc fault breakers. So I need to put a ground bus in here. A lot of times when you get a panel like this, you're going to have to put on a separate ground bus. So in this case, I actually got two, one for each side, because I know I'm going to need a lot of connections in here. I bought one from my local electrical supply store, and it also came with another one, which actually extends, and this one extends so that there's actually two of them. So we're going to put both of these in, and both of them come with a lug here that's meant for 2-aught or smaller. So at this point, because I got protection in here, I got this breaker off, and I got these on here. Now I can go hook up the other end and turn it on immediately, and then I can just finish out in here. All right, so first thing I do here, cut the power off. The meter is still going to stay active. Maximum time. I'm not even gonna put a fucking loop on. Ooh. that on. That's gonna reset. There you go. Now we got power. I actually ended up hitting rebar on this first one, so I just went 1.5 inches over, and then this one went through no problem. But that took all of like 30 seconds to drill that. Right there. Show a little shot of this. I got a load of crusher on over there. I'm just gonna put that over top of this, that way nobody accidentally trips on it or lands on that or something. Usually the inspectors want to see this exposed until they inspect it, but this gravel is easy to take off, so I'm just gonna put a little bit on top for now. When I get it inspected, I'll just expose it just so you can see it. So we got our 3 ground buses here, and our ground rod is tied into this one. And this ground right here is going back to the panel, and that's got 2 ground rods on that. So there's actually 3 ground rods hooked up to this all together. Plus I'm gonna hook to the water pipe. So we're grounded pretty good here. In the past, what I've done with building houses is put an oofer in the foundation, and that's basically just a piece of rebar sticking out, and it's 20 feet long. And then that suffices for a ground rod, but I actually forgot to do it here. I'm really kind of disappointed that I forgot that, but a 20-foot piece isn't easy to get here either, because you got to bend around all this stuff. But usually when you have a straight wall, you just put a 20-foot piece in and you just stick it right through, and then you just hook your copper right to that, and then that's your ground rod. Alright guys, so this is pretty much all wrapped up for right now. I'm gonna obviously do a lot more work in the future, but right now I can't run many wires in the wall because I got all this bracing. So in a few weeks when I take that down, then I'll start channeling in the foam to run all of my Romex in here. And I'll at least get this basement all wired up, put some outside lights on, some outside outlets, and gonna install a tankless water heater here for this radiant system. That's gonna be the next video. Gonna just hook up the loops in this slab. That way we can heat it in here without using a space heater. I have an existing electric tankless heater I'm gonna use for that, so that's one of the reasons I needed to get that power on as well. One thing I would suggest, if you're gonna go the route that I did and use the URD wire in here, I would make sure that it's rated dual use. Because if it's not, then you're not allowed to bring it inside of a home, a residential house. So the wire that I used was dual rated, dual purpose. So it's actually rated to go inside of a house, but it has to be in conduit all the way to the panel. So that's one thing that you have to follow. For me, that's no big deal. Some people might not care to do that. If your panel is a long ways away from the wall and you have to run conduit all over the house, that may not be reasonable for somebody to do. But I always try to plan it out where it's like right behind where it goes in. That way, obviously I only have a few pieces going in, so that's no big deal. But ideally, copper would be a great conductor for this, and I could have got away with 2/0 instead of 4/0. But copper is super expensive, and if I'm gonna be getting the same amps out of it, then I'm just gonna go the route that's thousands of dollars less. Because this URD wire at 200 feet was around $800. Copper was $4 a foot just for one 2/0 wire. So then you also gotta have another one, and then you can downsize the neutral and you can downsize the ground, but still, I was looking at around like $3 grand for copper versus $800 for this aluminum. So obviously copper's a lot better, but in this case it doesn't really matter. I'm not gonna be anywhere as close to maxing out that load anyways. The geothermal system takes 30 amps, and that's pretty much going to be taking care of the biggest load in the house. What I'm going to do for this radiant heat is like a budget type system where all the parts that I'm going to be using are temporary, because I'm obviously going to have my geothermal system, so I don't need an electric tankless heater. But I have all the parts that I need, and the parts that I don't have are going to be used for my snow melt system in the driveway. Like I got a 3-port manifold, and I'm going to use that for the driveway heat and the roof heat for the snow melt. So nothing's going to be wasted, and nothing is being bought just for this temporary hookup. Everything's going to be reused or something that I already have. So that's going to be in the next video. So I'll catch you guys on that one.